Welcome to the M350 Mapping Features tutorial video. This tutorial will introduce the operation essentials of the Zenmuse L1 and P1 in mapping missions. Zenmuse L1 mission planning for laser modeling. Preparation. Install the L1 gimbal on the single downward gimbal mount of M350. Turn on the remote controller and aircraft. And launch the DJI Pilot 2 for self-check. After completing the check, select the corresponding RTK service type in the general settings. This video uses the custom network RTK as an example. After confirming the connection status is normal, wait for the preheating to finish. Click the flight route icon or create a mission in the flight route menu. This video uses the mapping mission as an example. Basic parameters. Choose the camera, Zenmuse L1, and LiDAR mapping. If there are tall obstacles between the takeoff point and the start point of the flight route, set a safe takeoff altitude value, higher than the obstacle height. The drone will first climb vertically to the safe takeoff altitude, before flying to the start point. For IMU calibration, the aircraft will automatically fly forward and backward, in the yellow flight segments, aiming to maintain accurate precision. It is recommended to keep this feature enabled. Terrain following. If the terrain is uneven, enable the terrain follow feature to ensure uniform point cloud density and flight safety. The M350 supports two ways for terrain following: local import and network download. This example demonstrates the network download. Click on Download from Internet, and the elevation data based on the survey area location will be downloaded. Once the download is successful, a yellow area will appear. Planning and adjusting the flight route within this area will be based on the terrain following altitude data, displayed in different color gradients. When the survey area boundary points exceed the yellow area, the portion outside will lose terrain following altitude data. You need to download it again to cover the entire survey area. Downloaded DSM files will appear in the list. If they are no longer needed, swipe left to delete. It is recommended to set the terrain following altitude between 50 and 100 meters. Altitude setting. When the terrain follow feature is disabled, set the flight altitude mode, which defaults to relative to takeoff point. The recommended operation altitude is between 50 to 100 meters. Advanced settings. In advanced settings, adjust the LiDAR side overlap, visible forward overlap, margin, and photo mode. LiDAR side overlap ratio is 20% by default. To improve the point cloud density and model accuracy, you can increase the overlap appropriately, keeping other settings at their default values. Payload settings. In the payload settings menu, you can choose between single, dual, or triple for return mode. Generally, it is recommended to use dual return mode for scanning the power channel, which can balance point cloud density and efficiency. When creating a DEM, select dual or triple return mode to obtain more data. It is recommended to choose the highest sampling rate. There are two scanning modes, repetitive and non-repetitive. Repetitive scanning offers higher accuracy and greater point cloud density, while non-repetitive scanning has a wider scanning angle and provides more facade information. Generally, it is recommended to use repetitive scanning for basic surveying, and non-repetitive scanning for power channel or building scanning. RGB coloring is enabled by default, and uses the visible light camera to capture photos for coloring the point clouds. It can be turned off at night. Additionally, images captured by the visible light camera can be used for 2D or 3D visible light model reconstruction. Click the Save icon to save the mission. You can also view the mission from the flight interface. Check the status bar to ensure that everything is normal. Click the flight route icon, select the mission, and click Start. After checking, upload and execute the mission. Point Cloud Preview. Enter the flight interface to view the point cloud and visible light images, which can be switched using the side button. Click L1 to switch to the split screen interface, to simultaneously view visible light and LiDAR point cloud. Adjust the color display mode using the R1 button. Click R2 to view the real-time point cloud model. Manual point cloud recording. Zenmuse L1 supports manual point cloud recording. After completing the preparation work, click the record icon to start recording the point cloud. After the recording is complete, click the record button again to stop recording. Zenmuse P1 Mission Planning for Smart Oblique. Basic settings. This section will introduce how to use DJI Pilot 2 to plan Smart Oblique mission for the Zenmuse P1 camera. Open DJI Pilot 2, enter flight route, create a route, and select Mapping Mission. Create an appropriate modeling area. Set a mission name. Choose the camera's current focal length. Set the appropriate flight route altitude. And choose whether to enable terrain follow based on your needs. The operation method for terrain follow flight is the same as with L1. Smart Oblique. Enable the Smart Oblique function and set the gimbal angle according to your needs. At this point, the software will plan a Smart Oblique route based on the set shooting area. During the operation, the gimbal will rotate and take images in 4 directions according to the angle, in addition to the vertical shooting images, to complete the oblique photography fieldwork. There is no need to set the flight route speed, as the aircraft will automatically adjust based on the progress of the mission, flying slower in the central area and faster at the edges. It is recommended to keep the course angle at the default setting. Set the upon completion action to return to home. The Smart Oblique flight route covers a larger flight area than the mapping mission. Advanced settings. Click on Advanced Settings to set the side and frontal overlap ratios. The default overlap rates are 70% and 80%, which can meet the needs of most scenarios. If you are in the general surveying and mapping field, and want to improve modeling efficiency, you can slightly reduce the overlap rates, but it is not recommended to go below 60% and 70%. Otherwise, it may not be possible to generate a model. Payload settings. In the payload settings, the default focus mode is set to first waypoint autofocus. Keep doer ping disabled. Complete the settings and save the current parameters. Execute the mission. Click the execution icon. Confirm the checklist and RTK status, check the surrounding environment, and upload the mission. During the flight, the gimbal will perform multi-angle photo shooting according to the mission. You can switch between the FPV and map interfaces to monitor the status of the aircraft and the mission progress. Please pay attention to flight safety.